So we're going to go ahead and start talking about functions. So what is a function? In algebra, you will be working with many different types of functions. Perhaps one of the most important definitions to remember in the algebra course is a definition of a function. So a function simply is a relation in which each input, an x value, has exactly one output, a y value. So you put a point in, you get a point out. Okay? So today you will look at functions in various forms, but you will begin with some real-life functions that you might experience every day. So let's look at exercise 1. Consider a computer keyboard. If the user were to press the following keys, what character would appear on the screen? Fill in the table below. So very obviously, if you're typing on a keyboard, you press B, you get the letter B. Same goes for F, W, the number 2, the number 9. So this is really pretending these are your inputs, these are your outputs. So for example, this might be an X value in this column and a Y value in that column. So like it says here, for every key the user presses, the inputs, the keyboard will display exactly one character, the output. This is an example of a function. So let's look at another real-life example, a thermometer. So let's take a look at the thermometer on the right side of the screen. What is the temperature in degrees Fahrenheit when it is 100 degrees Celsius? So our input is 100 degrees Celsius on the left side, and our output is over here. 100 degrees Celsius is the same as 212 degrees Fahrenheit. So that is our output. So the X value would be the Celsius, the Y value would be the Fahrenheit. So now let's go in reverse. What is the temperature in degrees Fahrenheit when it is 0 degrees Celsius? 0 degrees Celsius is the same as 32 degrees Fahrenheit. So that is our output there. Now, we need to make sure we know what we're talking about when we do this with numbers. So for exercise 3, it says examine the sets of points below and determine the sets that are functions and the sets that are not functions. So let's take a look at A. How would we know if this is a function or not? So we see 3 is an X value, 2, -3, and -7. Now, all the X values are different, and they also have different outputs. So yes, this is a function for that reason. Now, if we look at B, we have -4, we have 3, we have 7, and we have 3. There's an issue here. This would not be a function because we have a repeating X value of 3, so not a function. And that reasoning is because of a repeating X value of 3. Let's look at the other two now. We have 10, 4, -2, and 0. This would be a function, and that is because we have different X values here giving us different outputs. And then our last one here, we have 0, 0, 1, 1, 2, 2, and 3, 3. This here would be a function as well because we have no repeating X values giving us the same output. On to exercise 4. Examine the tables below and determine which tables represent a function and which tables do not. We're looking for the same thing here. We're looking for repeating X values. If we look at A, -5, -2, 4 and 4 is a repeating X value. This would not be a function. For B, all our X values are different, and we have different outputs. So yes, this would be a function. And our last one here, we have all different X values, but oh no, all the Y values are the same. That does not matter. We're only looking at the X values to tell if this is a function or not. All the X values are different. Yes, this is a function. On to the vertical line test. This is another way to tell if a graph is a function. So a vertical line test is exactly what it is. We draw vertical lines through the graph. What do we notice about the circle? If we draw vertical lines, it hits this graph twice. So what that means is that this is not a function. It fails the vertical line test. Now we have an upside down parabola or a negative parabola. If we draw vertical lines, it never crosses twice. So yes, this is a function. Letter C is a tricky one. Now, we draw vertical lines. It doesn't look like it's going to cross. Oh no, what happens here? We have a closed circle and an open circle. Due to the fact that there's an open circle, the graph does not exist at this point. So that means it does not cross both of them. So it still is a function. Here we have a bunch of random dots or points in the coordinate plane. None of these are on top of each other, so yes, it still is a function. If there was a point, say, right here below this one, it would fail the vertical line test because it crosses twice. So the key thing here is we do not want any repeating x values when we have a function.